Thank you, Andy, for having me. Welcome. I'm going to talk about today continuous code promotions, which is actually getting quite a relevant topic when you start to scale GitOps. My name is Gabor Horvath. I'm a senior DevOps engineer at Raiffeisen Bank International. I am working in the company's platform team since a couple of years, but at the company since 7 years. And I have expertise in Kubernetes, and I have interests in CNCF technologies and projects, and I'm passionate about it. About RBI, so we are one of Austria's leading corporate and investment banks. We have 11 subsidiaries in the Central and Eastern European region. We have 18.1 million customers and around 43,000 employees. We have a booth here, so if you are interested, please connect with the colleagues. So to give you a little bit of background information or some kind of context, I would like to talk to you about the history of the runtime platforms at RBI. So traditionally, we had two legacy platforms. One was called Merlin, other coming out from an innovation project called Cortex. And there were some differences between these two platforms. One was an old push-based CD approach used there. Other was more GitOps-oriented, built around Kubernetes. And also, it was a shared cluster in Cortex, and it had some basic promotion capabilities based on Argo framework, and it was also infra-agnostic. In comparison, the Merlin was more focused on self-service around AWS. We were providing some kind of infrastructure as a service libraries for consuming for our internal customers. And there we had no GitOps at that time. And then around 2 years before, we had a strategic decision from the leadership that we would like to streamline these two platforms, and we would like to optimize the costs and simplify the operations, and we merged these two platforms into the one. And this, of course, also introduced a new kind of challenges. We wanted to use shared OKD clusters. So OKD, if somebody is not aware, it's an open distribution of OpenShift. And we wanted to put multiple internal customers on that dedicated cluster. And this, of course, required some architecture redesign. And more importantly, it also required to rethink how we do GitOps in a large scale, in a multi-tenant environment. And this brought in the question what ArgoCD architecture we should use, and also how we should promote the releases between environments and clusters. So what options we have for ArgoCD architectures? Of course, scaling GitOps with ArgoCD is depending heavily on the architecture choice. So we at RBI building on open source, and we had to put really quite some effort to basically figure out how to efficiently use ArgoCD, because I heard it in one of the YouTube videos around Argo that Argo is really easy to learn, but it's hard to master. Yeah, there are some questions how to patch, tune, and also individually you can tune the components, and that's why it's an important question to solve that. So there are three deployment models, what I will guide you through. One is the single instance model, where you need a management cluster. The second is a per cluster instance model. This is actually where we settle down at RBI. And there is also a kind of combination of both, where you have a logical group of instances. So for the single instance model, the key characteristic is that you need one ArgoCD control plane in the central, which is managing all the remote clusters. So this means for the users, a single, or for the operators mainly, there is a single API or CLI endpoint and also single UI. But this also needs network access to all the remote clusters. There are, of course, some pros with this architecture, that you have a unified view for all the applications. And also you can have simplified maintenance and management. And it also have good integration with the application set cluster generator. But of course, there are some cons. It's like, if there is something happens with this central management cluster, then it's affecting all the managed remote clusters. And also you would need to dedicate a management cluster for that ArgoCD. Also, it's a high value target because this central ArgoCD actually has credentials for all the remote clusters. And also there is a high network traffic across the clusters because the remote clusters, there are resources on it, and it's continually watching the changes, and it needs to communicate back to the control plane, to the ArgoCD control plane. The other choice is when you can have a per cluster instance. This is actually where we what we use. So you have one ArgoCD deployed in every cluster, in every Kubernetes cluster, and you don't need to expose the cluster APIs, and this increases the security, and there is no need for central management cluster. So the benefits of this architecture is that you can distribute the load evenly across the clusters. There is an increased security because you don't need to share with the central Argo the credentials. There is no network traffic or high network traffic because ArgoCD is running locally in the cluster, and it doesn't need to send back anything to the central. And it's easier for scaling the larger distributed environments. So, of course, this also means that you have to maintain more ArgoCD. You have some configuration application for the single sign-on repo credentials or RBAC, and it has not so good application set cluster generator integration. For the operators, it's harder to manage because you also need to know always to which cluster or ArgoCD you are logging in. And of course, this takes some compute resources for the clusters where ArgoCD is running. But I will address these disadvantages later on. And of course, there is the combination of the two. You can have per logical group, you can introduce an ArgoCD, which is then managing those remote clusters. And this is more like a balance between a single instance and the dedicated one. So for the per cluster instance types. Okay, so here the benefits are that you can distribute the load amongst the ArgoCDs. You have some fault isolation, you have reduced configuration application. Also, you can use still application set cluster generator, and it's a single view per group. But of course, again, some disadvantages. You still require multiple Argo. You need management cluster. You need still tuning at certain scale. And again, you have to know where to connect. But you can imagine like you have one team or one region, and you dedicate their ArgoCD, and this is managing that team's clusters. Okay, so why RBI chose the per cluster instance architecture? So as a regulated bank, for us the security is really top priority. There is no need for sharing credentials outside the clusters, as I said before. Basically, ArgoCD is running in its own service account, or with its own service account in a local cluster, and talking directly to the API server. Of course, fault tolerance is given in that way, and the blast radius is minimized. So we have, if there is one ArgoCD down, then only that cluster is impacted. It has better scalability, so you can still tune each individual ArgoCD per cluster. No need for complex networking, or you don't need to expose the cluster API. So if you have remote clusters and you have in different VPCs, your ArgoCD you don't need to expose. And the downsides, which I mentioned before, we address it by using ArgoCD operator. So of course, you have to invest some time to do some strong automation and repeat the configuration on every cluster. Okay. So just to summarize, use single instance for the small and simple setups, and use per cluster if security isolation, scalability, fault tolerance is a top priority for your company. You can also use logical group instance model. If you have a middle-sized company, then you can go with that one. And of course, use automation. Okay, so let's talk about promotions. So in GitOps, promotion is actually moving a release artifact between environments, or through environments, from dev to stage and finally to production. And this usually means, I think everyone who is practicing GitOps knows here that you make the changes via git commits or pull requests, and that is reflecting in the live environment. But in GitOps, this is actually a pain point because the standard GitOps, let's say, rules are not addressing the promotion workflows. So people are solving differently how they promote further. So I think if I would ask here, how are you doing the promotion, I would get probably different answers. So there is no standardized way for that. And this complex promotion logic, like these quality gates, approvals, visibility, they are really hard to manage with the basic GitOps principles. So we also, as I mentioned, in our legacy platform Cortex, we had some kind of Argo framework related promotion, but then we conducted some kind of survey within our customers, and we got the feedback that there is lack of visibility. It's unclear what version is deployed where at any given moment, and also the promotion process itself is not so intuitive. Yeah? So like they were struggling to revert, to promote further, and to do it in a user-friendly way. We were exploring some solutions. We first tried Captain, but we saw that the maintainer was changing the focus and the scope was a little bit adjusted there. And we also tried Devtron, but it was too opinionated. So then what we chose, we made some research around Kargo, which is an emerging continuous promotion tool built on GitOps principles. And what it basically means that the developer is making a change in a container image or in a Kubernetes manifest or configuration. This change is getting detected, so the artifactory or artifact store is continuously monitored by Kargo, also the Git repository. And if Kargo detecting this change, then you can promote this change. You can also do automatically. And in the end, finally, it will also sync the application with ArgoCD. And of course, not to forget, verification is also possible, very important for the quality gates. This is all good, but the challenge was how to run it in a scalable and distributed way. And yeah, because the problem was what we see in the very beginning, that the Kargo UI and the control plane on every cluster, it was not so feasible to deploy everywhere. And then we couldn't expect from our customers that they know, okay, if you want that cluster, then go to that Kargo UI. If you want something else, then go to another one. This was one problem that we wanted to address, and the other that the Kargo control plane actually couldn't access the ArgoCD of a remote cluster, so it couldn't trigger a sync. And RBI is an early adopter of Kargo. We initiated conversation about how this should work, how the remote Argo connection can work, how it is working in an air-gapped environment. Actually, my colleague Marcus was contacting with the Kargo colleagues via GitHub discussion. And then we try to experiment with it because Kargo is actually not really documenting this. Yeah, they have some basic features of sharding, but they are not explaining in detail because this is one of their main feature in the other offering what they have, Acuity platform, I think it's called. So yes, this was our solution to logically partition our workloads and stages into shards, and each shard is managing an application and a stage or an environment independently. So just to go into the architecture a little bit. So what I want to explain here, and I hope I can do it in a clear way. So the developer has a single Kargo UI. So this is the entry point for the developer. And then you have sharded Kargo instances. So there is a central one. This has the UI, and it has a sharded controller. And then this central Kargo is storing all the Kargo resources. So other clusters, they do not even have Kargo CRDs, only the central one. Actually, this is really helping in disaster recovery scenarios because we can only need to make backup from the central one. And then you have the sharded controllers. And here the important thing to understand is that they are phoning home or connecting back to the central Kargo. And then when there is the sync needed, then they operate alongside with the nearby ArgoCD. So that's why how we can use Kargo from here, but still triggering update on a remote cluster. Yeah, so also there is Argo rollouts working in every sharded cluster. And here the important thing also to understand that Argo rollouts is also phoning home or connecting back to the central one, creating the analysis run. And analysis run is creating a job, but the job is created locally in cluster. So it's important to test wherever you promote it, right? So we cannot test the software on the central one because the software is running on the sharded one. So actually this Argo rollout is having two kind of kube configs. One is talking back to the central one, other is locally talking. So this is the architecture. And yeah, so this is how our customers are using. They promote and then they can trigger verification. And that's actually our scalable continuous promotion. So now I would like to show you a quick demo. I still have some time, I think. All right, so I hope it's visible. So what I would like to demo to you, here we have Kargo. Let me zoom in a little bit. So here you see we have kind of 3 stages. Out of these three stages, 2 are dedicated to one test cluster, and the third one is a production cluster. And what I will mimic here is that I will simulate that the developer is committing something to the repository. And what we will see that Kargo will observe that there is a new commit. It will create a so-called new freight on the freight timeline. So freight is the release artifact which you move through the stages. And on the left side, on the top, I have a test cluster, and on the bottom, I have a prod cluster. And what we expect is that once I commit, the freight will be generated, and because of auto promotion, it will go through on all the stages, it will be promoted. Of course, it's not a good practice that you immediately promote without any quality gate or any approval to production, but for the sake of the demo, I just want to show you that this is supposed to work. So let me commit something here. Okay. Okay, so yesterday I had a bypass. Okay, I will pull up the video because normally I would need a pull request here. So let me pull up the video. All right, so I will try to comment. So what you can hopefully see that I'm making a commit, directly committing to it. And I want you to focus here that it was successfully synced 9 minutes ago, also 8 minutes ago. And soon when it will go through on the promotion pipeline, you will see that it's immediately synced. So we triggered ArgoCD sync remotely. So now the commit was done. And on the stage, you see that the verification is triggered. So Argo rollout is doing the verification. And once the verification is finished, then it's moving to the test. And it will do the same everywhere. And here you see it's changed that succeeded few seconds ago. So it was triggering ArgoCD update. Yeah, it's not easy to demo because when everything works, then of course it's not so beautiful. But I want you to understand that we are really working with remote clusters from one central place. And I think this is really helping for developers and also for us when we scale with GitOps. All right, so let me go back to the slides. So I hope this was valuable to you. Thanks for listening. And if you are interested, please scan the QR code. We have open positions. And also visit our colleagues at the booth. Yeah. Thank you. Thank you.
I told you, I know you were nervous in the beginning, but it was awesome, right? Because this is your story that you tell because you've built this. So folks, be encouraged to also get on stage. And remember, for tomorrow, we still have a 15-minute slots available. If you have a topic, let us know. Let me know or Daniel. Now we have 2 minutes left for a question. Any questions? We have a mic runner. Here we go. Fourth row. He's not only a mic runner, he's also a Haribo runner. We got cookies for you, or at least some sweets.
Hello, hello. You showed in one of the slides that you had, I believe, 3 different test stages. One was called Nebula and two were called Voyager or something.
Yeah.
In this architecture, how long would it take you to spin up another test environment?
So it's a shared cluster, and we have ephemeral, let's say, CI environments. So it's actually a matter of GitHub workflow automation to have it. So this is what we are offering to our customers, that they can create ephemeral environments because it's a shared cluster. So what we are offering on a shared cluster, we have a namespace dedicated for a customer, isolated with network policies, everything. And yeah, this is a matter of, I think, minutes. So this is how we are approaching this.
This question has a second part. And have you considered to create test environments per feature branch?
This is actually working like that, this ephemeral CI solution. So it's customers are using for feature branch development. Yeah. And then it will appear in Kargo because we have behind some kind of application set automation, and they can dispose it when they don't need it anymore.
Amazing. Thank you.
Welcome.
Awesome. Thank you so much.